Hi guys, my name is Terry. In this video, I'm going to go through the SPM trial paper year 2022 for the subject additional mathematics, and this is Mrsm paper 2. Okay, let's get started with question number 1. Now, I will say this question is rather simple, compared to normally the Mrsm standard. This is pretty easy. This is from the chapter system equation. Here we have two equations. One linear and one non-linear, all right, and involving x and y. So here, I think we can start off by making either x or y as a subject from the equation 1, and we sub inside equation number 2, all right? So this is your equation 1, this is your equation 2. I think the easiest way is to make x as the subject. Reason being, if you make x as a subject, I can just substitute directly. If I make y as a subject, I have to square it, and then I have to sub inside and multiply with 2, right? So it's a bit longer. So coming from equation number 1, from equation 1, I think we can first divide everything by 2. You get y equals minus x minus 5. Now, I know you can also take the y and sub inside, but like I say, when you take the y sub inside, you will have to substitute first, square it, multiply by 2. So it's a little bit longer, okay? Now, let us bring the x to the left, y to the right. So my x equals to negative y minus 5. We're going to call this equation number 3. Now, as I sub equation 3 inside equation 2, you will get 2y squared plus x. My x is negative y minus 5, and then the result is equals to 5. So let's bring this y to this 5 to the left. You will get 2y squared minus y minus 10 equals 0. So what we have here is a quadratic equation. We take 2 times 10. 2 times 10 gives us 20. Factor of 20, 20 and 1. We also have 10 and 2, 5 and 4. The combination that gives us 1y in this case is 5 and 4. So we're going to pick 5 and 4. Now let's double bracket factorize them. Okay, I think it's better for me to write over here. It's easier to see. Double bracket factorize them. So you have to use 5 and 4. But remember, you need to begin with 2y and y so that this will give us 2y squared. To get 5 and 4, meaning this must be 4, this has to be 5. Now we can't get 5 here because 2 times anything will never give us 5. It can give us 4, so I'm going to put a 2 here. The other one will be 5 here. And since I want negative 1y, the bigger number 5 is negative, smaller number 4 is positive. Now, this one is going to give us negative 5y plus 4y, which gives us minus 1y. All right, so let us solve for y. Your y is now, remember, 2y minus 5 is 0. Y is 5 over 2, all right? And y plus 2 is 0. Y is negative 2. Now, you have 2 answers for y. We should have 2 answers for x. Let us just sub inside equation number 3. Well, your x value is now negative 5 over 2 minus 5, which gives us negative 15 over 2. And the second value of x is negative 2 minus 5, which gives us plus 2 minus 5 minus 3. Plus 2 minus 5. What is a minus here? Minus is a plus. Okay, let's move on to question number 2. So in this question, we have to prove trigonometric identity for the first part and sketch a graph and find the number of solution for the second part. Okay, so I think we'll start off with part A. To prove that cotangent square over 1 plus cotangent square equals cosecant square theta, cosecant square x. I think we start from the left-hand side. Now, we always start from the side with more number of terms. In this case, is your left-hand side. Now, your cotangent square, I can't do anything, so I'm going to write this down. Okay, the 1 plus cotangent square, we can use the basic identity. I hope you still remember that cos square plus sine square is 1. When you divide by cos square, you divide by sine square, cos divided by sine is cotangent, and then you have sine divided by sine, or sine square divided by sine square is 1. And 1 over sine square is cosecant square. Yeah, this formula is actually given in exam, so you can actually just refer to the list of formula and just substitute. Substitute 1 plus cotangent square or cotangent square plus 1. Substitute it, replace it with cosecant square x. Okay, now then look at the right hand side. What I need is cos square. I want to change to cos square. So I know cotangent is cos over sine. So I can change this to cos over sine, but there's a square, so you put cos square over sine square. As for cosecant is 1 over sine, right? And we can cancel sine square and sine square. Now I'm left with cos square, which is the same as my right hand side. Yeah. So it's not too difficult. It's not too difficult. All right. Second part, we're supposed to sketch a graph. Okay, I'm going to draw my graph over here. Whereas before you sketch this graph, right, you notice that you have y equals 2 cos square. Now look at this whole thing. Yeah. Maybe I should just highlight this. They are actually the same. See that? Okay. Actually, I should highlight the English version. Now, this is cotangent is with letter C, right? So we're going to replace this entire thing with cos squared. So what we have here, B Roman 1, is y equals to 2 over cos x. This entire thing is now cos squared x. And then you have a plus 1. Now, as we can cancel cos and cos square, now I'm left with y equals to 2 cos x plus 1. Okay, so we can now sketch this graph. Okay, I think I'll draw the graph over here. Yeah. Remember, cos graph, the basic cos graph looks like this. It goes down and up, maximum 1, minimum -1. This is 2 pi. Now, the thing is, because you have a 2 in front, now this is basic cos x. The moment you have a 2 in front, yeah, 2 cos x here, you need to stretch the graph up. So you have what we call an amplitude of 2, maximum 2, minimum -2. But I still have a plus 1 here, right? That plus 1 here means I'm going to shift the graph up by 1. So starting from 2, when I shift up by 1, my maximum is 3, right? My minimum before this is -2. I shift up by 1. -2 plus 1, my minimum is -1. So the point in between, the line in between, or we call the line of equilibrium, is here, is at 1 now, because I'm shifting the whole thing up by 1. Maybe what I can do is I can draw the x-axis here, draw a dotted line. Now, to be able to sketch a balanced graph, I would suggest that you divide evenly like this. You use your ruler. Yeah, you'll be better with the proper line segment. All right, so that is balanced. This is now 2 pi. This is now pi. This is pi over 2 and 3 pi over 2. Okay, remember the graph is supposed to start from 3. It's supposed to go down here. Before this, it's at 0. When you shift up by 1, it has to pass through this point here, 1. And before this is at -2. -2, when you shift up by 1, it's at 1 now. Then it moves back up to 1. And it has a maximum of 3. So your graph should be going down this way. Oops. And another thing is you probably want to use a thicker line, because when you use a thicker line, it will help to hide, the ugly drawing, right? So your line will be, your graph will look a lot better with a thicker line. Use 2B pencil to do it. Okay, let me just adjust it. Oh, sorry. Okay. Now let's draw a curve like this. Okay, this is a bit ugly. Let me just draw like this. Down. Okay. A bit too far. This way. Up. Okay. This way. All right. My maximum is 3. Okay. So from here, I got the graph of y equals to 2 cos x plus 1. So what I need to do next is for Roman 2, this is B Roman 1, I've done my graph. B Roman 2, they say, hence, using the same axis, sketch a suitable straight line to find the number of solutions to this equation. Now, if you look at this equation, it's the same as what we have above here, right? Where the 2, maybe I highlight this whole thing now, this whole thing here, as you can see, they're the same, right? Now, we already know that this is the same as our 2 cos x, right? So I'm going to straight away replace this with 2 cos x and let it be x over pi minus 1. Now, what I need is to rearrange the equation such that one side of this equation must equals to 2 cos x plus 1. So I'm going to add 1 on the left and on the right. Yeah, or should I say just bring the -1 to the left? All right, so we have two graphs here. The first graph is 2 cos x plus 1, which is what I really have here. And the second graph is the graph of y equals x over pi. Now, y equals x over pi is actually a straight line graph. Yeah, it's a straight line with a gradient of 1 over pi, and your y-intercept is 0. But if you're not sure, it's best we use a table of values. Now, when you use the table of values also, we always use the smallest and the largest value of x given here. In this case, 0 and 2 pi. So I'm going to put 0 here. I'm going to put 2 pi here. As I substitute 0, my y is also 0. As I substitute 2 pi, my y is now 2. Now we know 2 is around here. So maybe I use a blue color line, easier to see and see the difference. This is 0, 0. 2 pi and 2 is here. I just have to draw a straight line and oops, my straight line is a bit too far up. Oops, sorry. Okay, my straight line should be, okay, it's not very straight. Okay, I think it's all right. Yeah? Y equals to x over pi. So now remember, the number of solution to this equation is the number of intersection, is a point, the number of intersection between these two graphs. Yeah? Remember, this equation is valid if this, should I say, the y value of this is the same as y value of this graph. Yeah, both of them have the same point of intersection. And your point intersection in this case, you can see one is here. Okay, maybe I use a red color pen. One is here, one is here. They do meet at these 2 points. So with that, we can conclude that your number of solution to this equation is just 2. All right. Okay, question number 3. So here we are given d dx of 3x squared minus x equals to fx. This is from the chapter integration. So find the value of integration 0 to 3 fx dx. Again, I find this question is quite pretty simple and straightforward for Mrsm standard, right? So when you differentiate a function, you get fx. Remember, integration is a reverse process of differentiation. So when I integrate fx dx, I'll be getting back 3x squared minus x plus c. This is an indefinite integral. Indefinite integral, we always have to put a plus c. When there's no limit, we have to put a plus c. Now, as we sub in the limit 0 to 3 fx dx, now this time we have to put a square bracket like this, sub in the limit. Yeah, here the lower limit is 0, upper limit is 3. We put 3 inside here. 3 times 3 square, and you minus 3, and we sub 0 inside. 3 times 0. In fact, you don't have to write 0 like this. I mean, you don't have to put in this way because the entire thing is just 0. Now, what we have here is 3 square. Okay, sorry, this is 0 to 1. I've seen wrongly. Yes, 0 to 1, not 0 to 3, yes, 0 to 1. So my limit is actually 1. Okay, limit is 1. You square it, this is 1. So 3 times 1 squared is 3. 3 minus 1 is 2. This whole thing is 0. Answer is just 2. Okay. But it's just the first part. The second part of it is this. The gradient function of the curve. Okay, let me move this down a little bit. It's a bit too high. Okay. The gradient function of this curve is 3x minus h. Okay. Gradient function is actually my dy dx. So we know your dy dx is 3x minus h. Okay, let me just adjust it once again. Dy dx is 3x minus h. Now, they say the tangent to the curve at this point intersect the x-axis, cut the x-axis at this, right? So maybe I do a sketch for you. So this curve, I don't know how it looks like. Maybe perhaps looks like this. The tangent to the curve intersect the x-axis at this point, 3.75. You can write 3.75 is 0. Now, this the tangent to the curve at 7.5. 7.5 is here. All right. The tangent intersect the x-axis or cut the x-axis at 3 and 3.750. So number one, we cannot say your gradient. We cannot calculate the gradient. I know some people calculate the gradient directly this way. We cannot find the gradient by substituting x inside yet, because if you sub inside, you will get what we call in terms of unknown, right? So we put x equals to 5. My dy dx is 3, 5 minus h, which is 15 minus h. Yeah, that is in terms of unknown. But if you look at my sketch, you can see quite clearly that we can find the gradient of this line. We can find the gradient tangent. This line is a tangent because we know the coordinate of these 2 points, 1 and 2, right? So my gradient is now y2 minus y1, x2 minus x1. Yeah, so let me use a calculator here. Let's take 7.5. You minus 0 is still 7.5. You divide by 5 minus 3.75. So what I have here is just 6. Yeah, my gradient is just 6. Now we know gradient of tangent dy dx is now 6. And 15 minus h is therefore 6. And now we can solve for h. Bring over. My h is 15 minus 6. My h is 9. Yeah, first part is simple. Okay, now the question didn't actually ask you to find h, but we need to find h before you can find equation of the curve. Now, equation of the curve is your y, right? Maybe I rewrite first. My dy dx, I already know my dy dx is 3x minus h. H is 9. To find y, I need to integrate 3x minus 9 dx. Okay, so I hope you know how to integrate. Yeah, by now, yeah, when you integrate a function, what do? You increase the power by 1, copy x, increase the power by 1, divide by the increased power. Here, I'm integrating axn. We copy a, copy x, increase the power by 1, n plus 1, divide n plus 1 plus c. But when you're integrating a constant like a, what do is we add x plus c. Your constant here is 9, integrate 9, you get 9x plus c. Okay, so to find equation of the curve, I need to sub in a point. Which point? Well, as long as it passes through, the curve passes through the point. Yeah, we can't use 3.750 because the curve doesn't pass through this point. So we need to sub in 5 and 7.5. Okay, so when we sub in here, my y is 7.5, my x is 5 here, you square it, minus 9 times 5 plus c. Okay, let's count. We can use a calculator here. This is 3 over 2 times 5 squared. 5 squared, you can just write 25. 9 times 5 is 45. And this will give us negative 15 over 2. So let me write here. 7.5 equals negative 15 over 2 plus c. Let's just bring this over to the left, find my c value. Okay, so I'll take 7.5 minus answer. Yeah, minus answer. So there you go. My c is 15. Yeah, in fact, you know, 15 over 2 is 7.5. 7.5 plus 7.5 is just 15. And therefore, my equation of the curve is y equals to, take the c, substitute back inside here. My y is now 3x squared over 2 minus 9x plus 15. There you go. That's your equation of the curve. Okay, question number 4. This is the question from the chapter progression. So now it looks a bit complicated, but it's not really. Yeah? Now, diagram 1A shows the wave front. Actually should be waveformer from after a bed is dropped into water, into a river. Diagram 1B shows the plan of the wave form or wavefront form on the surface of the river. So both types of wavelength form geometric progression. So we can see from here, the length is actually increasing. You can see from here is increasing, right? Just show you the diagram. The wavelength is actually increasing. So, but actually that doesn't really matter, because what matters is the formula here. They give us this formula Sn equals to 5 over 2 plus 3 with a bracket 2 and minus 1 minus 1. So we're supposed to find the first part is the length of the first wavelength. Right. Now we know that S means sum of the first n term, and S1 is actually the same as T1. Yeah. So I know it's a bit strange because when we say S1 is T1, S2 is T1 plus T2. S2 means sum of the first two terms. S1 is sum of one term, first term. Okay, it's only one term, right? That's true. So anyway, this T1 is S1. To find the first wavelength, I substitute n with 1. Let's put it inside this formula here. This is 5 over 2. Okay, this is your I put Roman 1 here. 5 over 2 plus 3 bracket 2 power 1 minus 1 minus 1. So this will give us 5 over 2. Now we know 2 power 0 is 1. So you can write 1 straight away. 2 power 0. I can write 1 straight away. And that will give us 1 minus 1, which gives us 0. Your answer is just 5 over 2. Okay. So the first wavelength has the length of 5 over 2. Now to find common ratio, remember a common ratio in this is geometric progression. A common ratio is your T2 divide T1. To find T2, we have to use S2 minus S1. Yeah. Now remember, I said just now, T1 is the same as S1. S2 is T1 plus T2. If I want to find T2, I'll just take S2 minus S1 because when I subtract them, I'll cancel this off, right? Yeah. In fact, this is a general formula. Tn is given by Sn minus Sn minus 1. So my S2 I can find by substituting 2 inside this formula here. So we put 5 over 2 plus 3, 2 power 2 minus 1 minus 1. And since I already know my S1 is 5 over 2. Let us simplify this. This is 3. 2 minus 1. This is 2 power 1. 2 power 1 is 2. 2 minus 1 is 1 minus 5 over 2. As you subtract them, your answer is 3. Now, you don't even have to calculate what's your S2 because we can cancel this already, right? And you get your T2. And remember, common ratio is T2 divide T1. In this case, I take 3 divide 5 over 2. You flip it upside down. It's actually 3 times 2 over 5. So answer 6 over 5. Right? You can use a calculator if you want. Right? Okay. This is just the first part. Let's move on to the second part. Okay. It is given that 9T4 is 10T5. And the first wavelength from the source towards the riverbank is now 1 cm. That means I know my A is now 1. My A is 1. We're supposed to find the total distance of the wavelength when the wave front stops forming. You see, the first time you put the bait into the water, as you can see, you have what we call a waveform, right? So it goes like that. Then it starts to slow down until it basically disappears. And your wave front or your waveform, if you like, it actually gets smaller and smaller. At one point, it would actually it goes to 0. Okay. Now, that means we know we need to find your sum to infinity, right? So, but first we need to find what is your common ratio R. So use the formula. Remember, for geometric progression, Tn is A R n minus 1. So here my A is 1. My R is an unknown. If my n is 4, 4 minus 1 is just 3. This is 10. A is 1. Let me put a 1 here. R is an unknown. Power 5 minus 1. I'm going to write this as 4. So this is basically 9R3 equals to 10R power 4. Let's bring this over to the right. So we have 10R power 4 minus 9R power 3. The result equals 0. Now we can take out common factor. I can take out R power 3. That will be 10R here, power 4, take out power 3, left with power 1, left with 9 here. I've taken out R power 3, I've left with 9. your R cannot be 0. Yeah, if your R is 0, let's say imagine your first term A is 1. If your R is 0, what happened to your second term? Your second term will be 0. Your third term will be 0, right? And so on. Yeah, we know R common ratio can't be 0. Therefore, your R in this case has to be 9/10. So it's like getting smaller until at one point it just disappears, right? And that happens when your sum approaches infinity, right? The number of terms, yeah, we call it approaches infinity. We use sum to infinity, yeah? And sum to infinity, as you know, is A divided by 1 minus R. My A is 1. My common ratio is 9/10. So 1 minus 9/10 is 1/10, and you flip it up, you should get 10. Now, if you're not sure, you can always use a calculator. 1/1 minus 9/10. There you go. Answer is just 10. All right. Okay, question number 5. This is from the chapter Coordinate Geometry. So diagram shows a point Q. Okay, maybe I move this up a little bit. I show you the English version. Diagram shows point Q that moves along a circumference of the circle with center S. Straight line 2x equals y minus 3 is a tangent. So this is a line. 2x equals y minus 3 is a tangent to the circle at point B. Intersect the y-axis at point A. All right. And point S is the image of point B under reflection. So when you reflect over, you can see if it's a reflection, we know that two things must happen. This must be 90 degrees and these two must be equal length. So meaning B is the midpoint of PS. Now, given that point P, B, and S are collinear, yeah, 3 points lie on the same line, yeah, and we are finding equation of locus of Q. Okay, Q is the moving point here. I can see Q is your moving point along the circumference of the circle. To form equation locus number 1, I need to know what is the center of the circle. Now, the center of the circle is point S. We can call it XY. So number 1, the first step is to find out the coordinate of point S. We can use midpoint. We know midpoint of PS is point B. Now, since we know P is -2, the x coordinate is -2 here. We add with the x coordinate point S, which is x divided by 2. Then your y coordinate here is 9. You plus with y, you divide by 2. The result is point B, which is 2, 7. Okay, so let's compare. So when you compare -2 plus x over 2 is now 2. We multiply over. -2 plus x is now 4. You bring over my x is now 6. Likewise, when you compare your y coordinate, 9 plus y over 2 is now 7. 9 plus y is now 14. 14 minus 9, your y is 5. Therefore, the coordinate of point S is 6, 5. All right. So that is the first part, part A. Oh, sorry, I haven't finished yet. I need to find the equation locus. I only found the center, right? Sorry. The locus is a circle. It has a common center, equidistant from point S, but we need to know what is the distance here. We need to find the length of BS. All right, so let's work out the length of BS. We know we can say your BS is actually the same as PB because these two are equal length, right? So we find the length of PB, right? BS equals to PB. Let me write PB here. And we can use 2 minus. Now, you can also use BS since I know point S, right, guys? I know point S. Maybe I just write S straight here. Your S is 6 minus 2 square plus 5 minus 7 square root. Now, this is 4 square and 2 square. You can use a calculator. 6 minus 2 is 4. You square it. 5 minus 7 is minus 2 square. You can write minus 2 if you want. It's the same as 2 square. Yeah. So this will give us 20, right? Square root 20 here. Now, then we know Q is a moving point such that its distance from point S is constantly square root 20. Yeah, it's the same as the length of BS, right? So we know QS is square root 20. Now let's just use the formula for distance, right? I'm using formula for distance here. I'm taking one more time, point Q is X, point S, we know S is now, I'm going to write 6, 5. So X minus 6 squared, Y minus 5 squared, the result is square root 20. So I need to square both sides. Let me expand, square the left, square the right. So this is X squared minus 12X plus 36. This is Y squared minus 10Y plus 25. Square root 20 squared is just 20. So add them up, X squared plus Y squared minus 12X minus 10Y, 36 plus 25 minus 20, 36, basically 36 plus 5. This gives us 41. You're not sure, you can just always use a calculator. 36 plus 25 minus 20, there you go, that's 41. So that is my equation of locus of Q. Okay, the second part, the next part, I hope you can read the part below here. If straight line BS is now extended to point N such that 3BN is 4SN. 3BN is 4SN. So we can say BNSN is 4:3. BNSN has a ratio of 4:3. All right, so too many lines, too many information here. So I'm going to rub this off. All right, I just want to focus on this line here, right? BNSN. Now, I don't know what's N. So maybe I use an unknown. Maybe we can call it HK. All right, BN is now 4. SN is now 3. That means that this should be 1 to 3, right? So we know point S, we know point B, we can find point N by using the ratio formula. The ratio formula is this, xy equals to nx1 over nx1 plus mx2 over m plus n. Then you repeat with ny1 plus my2 over m plus n. Now, the key thing is that the n and the x must be opposite. So when you multiply, for example, I let this be m, this is my n, right? Your n must multiply with the opposite coordinate, 2, 7. Yeah, your m must multiply with the opposite coordinate, hk, right? Okay, so let me just count. Now, we know S is a point in between 6, 5, right? So we take n, 3, you multiply with 2, m, which is 1, I multiply with h, you can write 1h, your total ratio is 1 plus 3, in fact, you can just write 4. Then we continue with the y coordinate. You take your n, which is 3, I multiply with a y coordinate 7, my m is 1, I multiply with my y coordinate k, total ratio 1 plus 3. So let's compare this now. 6 equals 6 plus h over 4. Let's solve for h, right? So when I multiply over, this is 24 equals 6 plus h. My h, bring over, is just 18, right? H, 24 minus 6 is 18. Okay, let me write over here. Now, for my y coordinate, I have 5 equal 21 plus k over 4. This is 20, 21 plus k. My k is -1. So I've got my x coordinate and my y coordinate. I know coordinate point N is 18 minus 1. But guys, I want to find the area of quadrilateral, OABN. Okay, so I've got all this already. Okay, where's OABN? So I know N, right? My N is now 18 minus 1. So I need to find point A first, right? OABN means I'm finding here. Oops. OABN. This is my quadrilateral, right? So I just need to find the coordinate point A. Well, A is your y-intercept of this straight line. So we can just rearrange it. make y as a subject. Y is 2x plus 3. So my y-intercept is 3. Therefore, my A is 0, 3. Now, remember, formula for area is half x1, y1. I start with point over O, continue with A, followed by B, 2, 7, followed by N, 18 minus 1. Then you repeat the first point. Remember, x1, y1, x2, y2, x3, y3. Yeah, I hope you remember this. Half x1, y1, x2, y2, x3, y3. If it's triangle, we stop at 3. Repeat the first point. If it's quadrilateral, we have x4, y4, and then you repeat the first point. Okay, so let us multiply downwards. Okay, so this is 0, 21 minus 2, 0. Okay, let me write down. 0, don't you write? This is 21 minus 2, 0, don't you write again? Then the other direction going up is 0, 0, 7 times 18. You're not sure. Calculator 7 times 18. This will be 126. All right, so let's write 126 here. And the rest is 0, right? Okay, so you have 21. Okay, did I miss out something here? 0. Okay, I think I made a mistake. Sorry. This is this is not 3, 0. This is 0, 3. Sorry about that. I wrote this wrongly. This is 0, 3. Yeah? The coordinate for point A is 0, 3. Let me just work it out again. So 0, 0 minus 2, 0. Okay, going up 0, 6, 1, 2, 6, and 0. So this will give us, let's use a calculator. Okay, let's move it over here. Minus 2 minus bracket, minus 2 minus bracket 6 plus 126. Well, this will give us 134, right? Half of 134, negative. It doesn't matter whether it's positive or negative, because if you use a clockwise direction, you will get negative. If you use anti-clockwise direction, you get positive. Let's take half of this value divided by 2. We just treat it as positive because area is always positive. So my answer for the area of quadrilateral OABN is now 67 million. Question number 6, this is from the chapter Circular Measure from 5 chapter 1. So the first thing is you're given a straight line BA is a tangent to a circle, right? This one is a tangent to a circle, it's 90 degrees. We know this is a circle ACP with center O and semicircle EAD with center P. Okay, so this is a tangent. And they say that your straight line is a tangent, circle ACP, EAD intersect at point A here and at point P. So we are supposed to find the value of K given that this angle AOP here is 113.56. This is in degree, and BO minus BA is K. And we're supposed to find the K. BO is the length from here to here. BA is the length from here to here. All right, so that means we need to find the difference between BO and BA. Now, first of all, I think when you're given the length of this arc 4.754 and you're given this angle, so that means we know we can use S equals to R theta. S equals to R theta. But before that, maybe I should convert this angle 113.56 convert to radian. And we can convert to radian by multiplying with pi over 180. Now remember in SPM, we always use 3.142 here. Look at that. Your pi is 3.142. So just type in, when you type in a calculator, please use 3.142 here. 113.56 multiply 3.142 divide 180. Guys, I got 1.98. Maybe I should write more decimal point. 1.9823. Yeah, 1.9823. So this is your angle AOB. Yeah. Okay. Once you know this angle, we can use S equals to R theta. Your R is the length of OP, which is the radius of the sector, not the semicircle, the sector. Sector of the smaller one. This I'm referring to this sector here. Okay. Now don't have to highlight this first. Now next, your theta is 1.9823. Let's find the value of R. I'm going to use my calculator. Take 4.754 divide 1.9823. Guys, I got 2.398. Yeah, my radius is 2.398 cm. Okay, so 2.398 here. Okay, now when you rotate this radius, right, we know that this is also 2.398. Now I want to redraw this triangle. I know this is a tangent, so I'm going to redraw the triangle like this, right? This is your A, this is your B, this is point O, this is 2.398. Because I need to find K, and K is a difference between BO and BA, right? That means I need to find both the value, the length of BO and BA. Now, we know this is 1.9823 now. So we're going to find the angle next to it. The angle next to it is BOA. So angle BOA in degree is 180, in radian is pi. We want minus 1.9823. Use your calculator. 3.142 minus 1.9823. Your answer is 1.1597. 1.1597. Actually, you don't have to use such an accurate value. Like for example, if you use 1.982, I think it's good enough. I just use one more decimal point. Yeah. Once you know this is 1.1597 in radian, we can use SOHCAHTOA to find the length of AB. Now we know that this is your opposite. For this angle, this is your opposite. This is your adjacent. Your adjacent is 2.398. And BO is your hypotenuse. So here I'm going to use tangent. Tangent 1.1597 radian is your BA divided by 2.398. So let's multiply over, okay? Use your calculator. Tangent 1.1597. Okay, calculator, please change to radian mode. Whatever I get, multiply with 2.398. All right. So when I times over, my BA is 5.501. 5.501. Okay, so that is the length of BA, 5.501. Okay, if I know this 5.501, I can find BO by using Pythagoras. Now, if you want to use SOHCAHTOA once again, like for example, you might want to use cos theta, can as well. Right, so in this case, I'll just use SOHCAHTOA 5.501 square plus 2.398 square. I put the square root over, okay, let's count, right? Take this answer square plus 2.398 square, right? Square root over, you should get 6.001, 6.001, yeah, 001. Okay, I got my BA, I got my BO. Now we want to find the value of K. Yeah, remember BO minus BA is your K. So K is your BO 6.001 minus your BA 5.501. The difference is just 0.50. Now you don't have to write so many decimal points because the question says give your answer correct to 2 decimal point. Yeah, so I'll just write 0.50. Yeah, in cm. Okay, next we are finding the area of the shaded region. So my shaded region, as you can see, is this part over here, right? The green part. Now you got to do a bit of planning first, because we need to take, perhaps I draw this line for you. This one is a sector of a circle. You can see that, right? We are actually taking, maybe I draw over here. This is one sector. You plus with this triangle, but you minus this sector here. So this is your ACO, this is your AOB, and this is your ADP. This is your ADP. Okay, your ACO is not a problem because we already know this angle. This angle over here is angle BOA, right? It is 1.1597, and we know the radius is the same as 2.398, right? So we got all we need, all the information we need to find area of this sector. But for this triangle, we know that these two are equal length, right? It's isosceles 2.398, right? We know this angle here, which is from the beginning at 1.9823. But the problem is to find the area of the last sector here, I need to find the length of AP because I do not know what is AP. And I do not know this angle, right? So if you base on this triangle itself, you can see that this is, if I redraw for you here, it looks something like this. Maybe my triangle is a bit too ugly, right? This is your AOP. And if I know this is 2.398, I know this is 2.398. This is actually a chord, isn't it? This is a chord. AD is a chord. And I know the angle is 1.9823. So we can use the formula for chord. Now, for those who do not know about chord, the formula for chord is AB is 2R sine theta over 2. Now, you want to use cosine rule? Can as well. You want to split into 2 and do 1 by 1 also can. Now, what I mean by split into 2, you see, a chord formula is actually derived this way. If this is AB, right, this is a midpoint, let's say AM, and this is O, right? The whole thing is theta. Half of it is theta over 2. So if I say sine theta over 2, and this radius is R, it is now AM divided by R. Your AM is R sine theta over 2. Your AB is twice, which is 2R sine theta over 2. Now, I always encourage you guys to use this because it's a lot faster, right? You don't have to split them, don't have to do 1 by 1. It's a lot easier than cosine rule, okay? So I'm going to use this formula, 2R sine theta over 2, to find the length of AB. So my R is 2.398, right? I need to times 2 here. There's a 2 in front. And then take the sine of 1.9823 divide 2, put a superscript R to indicate that it's in radian. Okay, calculator. Yeah, remember calculator is still in radian mode. 2.398, we multiply with sine 1.9823 over 2, right? This is in radian. Now, you can use degree. If you use degree, then you have to use the original value here, 113.56. Okay, so I'm just going to use this directly, 4.013. Yeah, sometimes your answer might be a little bit different because when we convert to radian, remember we use 3.142, which is already rounded off, so may not be super accurate. So this is 4.013. 4.013. Okay, 4.013 here. Now this is important so that I can find the area of this sector. Okay. Another thing I hope you remember, in Form 3, you learn that angle subtended at the center is always double angle subtended in the circumference. Now, the angle subtended at the center really heavy here, 1.1597, right? Can you see? Is this angle here? The angle subtended circumference is over here, which is A, B, D, or APQ, or APO. So now, this angle over here, we can find, right? We basically take half of 1.1597. So your angle AB D here is 1.1597, right? We divide by 2. Okay, let me write down 1 by 1. 1.1597 divide 2. I got 0.5799. Yeah, 0.5799. You can use more decimal point. I think it's enough. For significant figure, 4 decimal point is good enough. Now let's put them all together. Let's start off by finding the area of this sector. Okay, this sector is half 2.398 your R squared theta. Remember, area of sector is half R squared theta. My theta is 1.1597. Then you plus area of triangle. Now this triangle over here, I'm going to use half AB sine C. Yeah, half your AB in this case will be 2.398. Since your A and B are the same, so I'm going to times together, or we can just square it. Sine of the angle in between 1.9823 in radian. Then you minus this area over here. you minus this area over here. This area is your area of sector. Okay, we minus half 4.013 square, and your theta is 0.5799. Yeah, I must say, this is not difficult. It's just very, very long. Okay, so we take half, all right, multiply with 2.398 square, all right, multiply with 1.1597, then you add half, multiply with 2.398 square, multiply with sine 1.9823. This is in radian, and then you minus half. This will be 4.013 square, multiply with 0.5799. Okay, so guys, my answer is 1.300. Yeah, 1.300. Okay, just take note, your answer might be a little bit different from the marking scheme if we check, because I think because of the fact that I use this value here. Okay, so if you use your calculator in degree, just to let you know, if you use a calculator in degree mode 2.398, let's say I use sine 113.56 over 2. Okay, let's see. Yeah, there is a slight difference in answer because of that. Right, we take 2 times 2.398 sine 113.56 over 2. Okay, in this case, remember your calculator, you need to change to degree mode. All right, so this will give us 4.012. See this? This is 4.012. Okay, so when you replace this, right, with 4.012, you notice there is a slight difference in my answer. All right, now let's go back to, wait, let me just do this again. Half times 2.398 square times 1.1597. We add half times 2.398 square times sine. Okay, even this sine, right, you can actually, instead of using 198.23, we can use 113.56. Yeah, but if you use 113.56 here, please use your calculator in degree mode. That is in degree mode. So I'm going to use 113.56. Okay, and then I minus half. This will be 4.012. Now, this 4.012 now, you square it, you multiply with 0.5799. All right, 1.303. Yeah, 1.303. See, notice the slight difference in answer is because when we use this value in degree, then yes, you get this answer 1.303. If you convert to radian here, use this in radian, your calculator must be in radian. Well, now notice I use in radian here, right? The blue one, right? Then you will get this answer. So it's a problem with converting to radian because we are using 3.142, which is not exactly the most accurate conversion. I don't know why. Calculators pi is the most accurate, yeah, but why? I don't know why SPM still want to use 3.142. Yeah, this is actually a much better conversion value to do, right? Rather than using 3.142. Okay. Okay, question number 7. Now, this is from the chapter. It's a combination of the chapter certs, indices and logarithm, particularly certs, and also your logarithm. Sorry, not logarithm, the coordinate geometry. Now, so here we are given equation of straight line CD. Yeah, CD is given. This is your line CD here. Your equation is minus 3x plus cert 2y equals 1. Now, if you want to find coordinate point E, E is the intersection between line AB and line CD. Now, we already know line CD, right? We need to find equation of line AB. Now, it's not difficult to find equation of straight line AB because we know your x-intercept, we know your y-intercept. Now, some people may say use y equals to mx plus c. Yes, we can do that. Gradient is negative y-intercept, which is 2, over x-intercept is 2, which is -1. Since my y-intercept is 2, we say straight line AB has equation minus x plus 2. This is your equation number 2. So let us sub equation 2 inside equation 1. The moment you sub inside, you don't write y anymore, right? So this is set 2. My y is minus x plus 2, and your result is 1. Now remember, I'm solving for x. So let's expand this. Minus 3x minus set 2x plus 2 set 2 equals 1. So I am solving for x. So for me, I will bring all the x to the same side. Yeah, this 2x, right? It's actually better to bring this to the right, bring this to the left. So when I bring this to the right, you have maybe you put 2 set 2 minus 1. And then for this, right, I'm going to put set 2 in front. I'm going to put plus 3 at the back, right? So up to you. You may want to put it the other way around. Also can. So when I divide this, my x is now 2 set 2 minus 1 divide set 2 plus 3. I like to put the set in front because you can see that 2 set 2 is right. The set is in front. So it's easier for us to simplify. So here we multiply top and bottom with its conjugate. We call it the process of rationalizing the denominator. So if I have set 2 plus 3, its conjugate is set 2 minus 3. Conjugate is like a twin. If this one is plus, the other one has to be minus. The reason why we do that is because when you use a conjugate, when you expand this, right, when you have like a plus b and a minus b, when you expand, you should get a square minus b square, right? So likewise, what I have here when I expand, okay, let me expand the top first, the numerator first. This is a numerator. We're going to multiply 1, 2, 3, and 4, 1 by 1. So this 2 set 2 times set 2 is 2 times 2. 2 times 3 is 6, 6 set 2. There's a minus set 2 and a plus 3. As for your denominator, we have set 2 plus 3 set 2 minus 3. Again, is in this format, a squared minus b squared. Set 2 squared is 2. 3 times 3 is 9. Okay, let's simplify this. This is going to give us 4 plus 3, which is 7. Minus 6 minus 1 is minus 7 set 2 divide -7. Okay, I can simplify this further. Now, 7 divided -7 is minus 1. Minus 7 divided -7 is a plus. There you go. My x is minus 1 plus set 2. But we're not done, guys. The question asks for the coordinate. Coordinate means you have to find x and y. E is a point of intersection between these two lines. I've got my x ready. I need to find my y. Okay, so I'm going to sub inside equation number 2. My y is now negative minus 1 plus set 2 with the plus 2 here. Multiply inside is a 1 plus set 2 plus 2. My y is 3 plus set 2. The question say, give your answer this form. So therefore, coordinate point E, write the x first, minus 1 plus set 2, write the y, 3 plus set 2. Okay? All right, so that is your part A. Okay, part B. Given a distance between point E and another point is set 17, find the values of M. Okay, so point E we already know. The second point is given as this. So we know distance between 2 points. So the formula for distance AB, for example, is given by x2 minus x1 squared, y2 minus y1 squared. So my second point, I'm going to take this point. This one will be my x2 minus 1 plus m set 2. I minus point E. x1 is minus 1 plus set 2. Open another bracket. So maybe I put a square bracket here. I square it, then I continue with my y2, which is minus set 2 minus 3 plus set 2, close bracket square. This whole thing I square root it, the result is square root 17. Okay, now we can simplify whatever inside the bracket first. So I hope you can see that minus 1 minus minus 1 is going to give us 0. I still have this m set 2 minus Z2. So I'm going to put it together. M Z2 minus Z2 is M minus 1 Z2. Then you need to square it, right? And then as for the second one, I have minus 2 minus Z2. So it's going to be minus, minus, there's a 3 here. Did I make a mistake here? This is 3 minus Z2. Okay, sorry, I made a mistake here. This coordinate here is 3 minus Z2. Sorry. There's a 3 minus Z2 here for coordinate point E, right? Because earlier I forgot to multiply the negative, but there's a negative here. When you times in, it's a minus here. Can you see that? Minus here, sorry about that. So now let's cancel the minus 2 minus minus 2. These two can cancel. So you're left with minus 3 here. So I'm going to put a minus 3 here. I'm going to square it. And this is 17. Okay, by the way, I actually canceled the square root and square root. That makes it easier. We can get rid of the square root. Now, the next step is to square this bracket. Now, no need to expand the whole bracket. I just leave it as m minus 1 square. Z2 square is just 2. Now, minus 3, if I square it, I got 9, right? So take 17 minus 9. The 2, I can leave it in front. 17 minus 9 is 16. 17 minus 9 is 8. 8 divided by 2 is now 4. When we square root 4, we put a plus minus. There's a negative and a positive. 1 minus 2, 1 plus 2. Bring the negative 1 over, so it's a plus 1. Minus 2 plus 1 is minus 1. 2 plus 1, m is just 3. Yeah, so you have 2 possible answers. Okay, this is section B, question number 8A. Yeah? So this is a probability distribution. In particular, part A is a binomial distribution. So it is given that it's found that probability a patient experience side effect while taking a medication is P. Number of patients who experience side effect has a mean of 20. Variance of 16. You're supposed to find the value of P. So we know your mean is 20. Your variance is 16. So notice we know that mean is given by NP. Your variance is NPQ. So this is NP equation number 1. Variance is NPQ. 16 equation number 2. Now, let's take equation 2 divide equation 1. So my NPQ divide NP is now 16 over 20. So we can cancel this two, right? We can cancel NP and NP, right? I got my Q. 16 over 20 is now 3 over 4. 4 over 5. Yeah. So I've got my Q. I need to find my P. Now we know that P plus Q is 1. So to find P, I must do 1 minus Q. 1 minus 4 over 5. My probability of success P is 1 over 5. Okay? It's not difficult. This is Roman 1. Okay, Roman 2. If 10 patients are selected at random, so find the probability that 3 patients will experience side effect. Okay? So my N is now 10. My P is 1 over 5. You want 3 patients experience side effect. So 10 C3, P power 3, Q power N minus X or N minus R. This is 7. Okay, I hope you remember the formula is, let me write the formula over here. Px equals to R for binomial is NCR P power R Q power N minus R. Okay, so if your N is 10, N minus R, this will be 7, right? Your P is 1 over 5, your Q is 4 over 5. Just use your calculator. So you can use either this calculator, the black one, the class fees calculator. So this one I use 10C3 times 1 over 5 bracket power 3. Then I multiply with 4 over 5 close bracket power 7. Okay, so guys, I got 2013. 0.2013. Yeah, by the way, if you have this calculator, you can do the same. It looks like this. We press mode, go to 7 for distribution. You go to number 4 for binomial PD, go to 2 for variable, press x equals to 3 and equals to 10. My p is 1/5. There you go. 2013. Okay. All right. So that is just the first part, binomial. The second part B is a normal distribution. Okay. So here the diastolic blood pressure for women in a certain district follow normal distribution. Mean of mu. Mean is not given. You find the mean. Standard deviation is 50. So a probability that the blood pressure less than 72 is this. So we're going to start off by writing Px less than 72 is 0.4364. So let us standardize this. This is 72 minus mu, standard deviation 50. This is 4364. Okay, let's do a sketch. Okay, so I like to do a sketch. At least I know before you standardize is 72. After you standardize, it becomes 0. Yeah, remember, the formula for standardization is this: x minus mu over sigma. It gives us our z value, right? So this z value has to be on the left. This is 72 minus mu over 50, less than it is here, 0.4364. Now, be sure you do a rough sketch because remember, it depends on a couple of things. It depends on the sign here and the probability here. For example, if your sign is greater than, then you need to draw on the right. Because if it's greater than, then this is like this. The diagram looks like this. Your 72 minus mu over 50 is now on the right. If your probability, for example, instead of 0.43, let's say 0.63, then this is on the right. However, the area is now on the left, right? So remember, when you solve question like this, you need to do a rough sketch. And I always tell my student, use 3 steps. Number 1, you fix the position. When you fix either on the left or on the right. Number 2, you shade the region. Now, where to shade depends on the sign here. If it's less than, we shade to the left-hand side, right? Okay, number 3, we always have to counter check whether the area matches the probability. You see, this area is less than half, and your probability is also less than half, so it makes sense. If let's say your probability is 0.63, then your diagram is wrong. Your 72 minus mu over sigma is not going to be on the left, it's going to be on the right. Because when it's on the right, then the area is more than half. It matches the probability that we are given. Okay, so be careful. You need to fix the position, shade the region, and check whether it makes sense. Okay, next, how do you find mu from here? Okay, so we have 2 ways. Either you can use your mathematical table, which is kind of long. You're going to slowly find, what is the value again? 0.4364. 4364. I'm going to use this 4364. Where is 4364? Okay, 0.4364 here. 0.16. 4364. Yeah, I hope I'm right. Yeah, 0.16. Okay, I hope you can see that. So now, if you don't want to use calculator, you don't want to use a mathematical table, you got to use this calculator. Only this class width calculator can do the job. Okay, so you press mode, press 7, press 3 for inverse norm. Your area is 0.4364. And my answer, you can see 0.16. Yeah, but this calculator will give you negative because the area is always measured from the left, right? When you use mathematical table, it's basically on the right. So be careful with that. If you use a mathematical table, what does a mathematical table tell you? It tells you that z greater 0.16 is 0.4364. Now, 0.16 in this case is actually on the right. And this area is 4364. But we can see from our sketch earlier, it's supposed to be on the left. So what we have to do is we're going to flip this to the left. Since they are symmetrical, this one I need to put a negative, yeah, negative 0.16. So what is the difference? We need to put this, let it be negative 0.16, because if you put positive 0.16, the mu value will be different, right? So I want to find mu now. Okay, let's multiply 50 over 0.16 times 50. There's a negative here, so it's negative 8. Bring over, mu is 72 plus 8. My mu is 80. Okay, so that is only the first part. Okay, second part. A special treatment will be given to women who have diastolic blood pressure more than 144.1. Find the probability that the woman managed to get special treatment. Okay, so you must have the blood pressure more than 144.1. So this one is quite easy, just standardize it. So when you standardize it, is x convert to z, you got to minus your mu, divide standard deviation. So this is z more than, okay, let's take 144.1 minus 80. You divide by 50. So what do you get? 1.282. 1.282. So we know this one, 1.282. Okay, let me write nicely here. 1.282. You can use your calculator. If you have this calculator, you can just change your calculator mode to, press mode first, press 3 for stats, press AC, press Shift 1 for stats, press 5 for distribution, press 3 for R. Remember, calculator, you use R, 1.282. There you go, 0.0999. Yeah, 0.0999. It's a bit small, 999. Now, if you don't want to use calculator, you want to use this, also can, but a bit slow, 1.282. Okay, let me show you here. 1.282. You're going to read this value here. That means you need to subtract 4 from the last digit. You have 0.1003. You subtract 4 from the last digit, 0.0999. Yeah, I hope you can see that, 0.0999. Okay, so yeah, what if you have this calculator? Well, this calculator, you press mode 7, go to number 2, normal CD. Now here your lower is 1.282. Remember, this 1.282 is over here. Your upper limit is infinity. We normally write 999. It goes all the way to infinity, right? So you put 1.282, upper 999, then your answer. Yeah, same value. Now, hence, if they are 3,000, this answer is correct. Yeah, I found the probability, but there are 3,500 women in the district. Find the total cost of treatment if the treatment is worth 150 per person. So the model must find how many people actually get the treatment. Okay, number of people who gets the treatment, I just put NT here. Remember, the probability of someone who gets the treatment is number of people who gets the treatment over NS. NS stands for size of your sample space. So to find the number of people who get a treatment, I need to take the probability multiplied by S. NS. NS is the size. Yeah, how many people here? 3,500. So we can take 0.0999 multiply by 3,500 people. Okay, take this up, 0.0999 times 3,500. Okay, I got 349.65. We have to round off 340, 350. Yeah, your number of people must be a whole number. We take the nearest integer. So there are 350 people will undergo the treatment. Now, how much is the cost? Yeah, to find the total cost, one person, the treatment cost is RM 150. So for 350 people, we multiply 150. My cost is 52,500. Yeah, 52,500. Okay, it's time for some infomercial. So this is our Ability website. You can go to our website and find, say, e-courses. We actually offer e-courses which cover the entire Form 4, Form 5 syllabus, right? It's a very comprehensive syllabus, and you get free preview. You can actually study at the comfort of your own home, watch video over again. And this e-courses comes with modules, 4 books, hard copy books delivered to you. For example, you can click onto the Form 5 here. You notice you have 4 books here. And then this book, they're arranged according to topic. Topics included are listed here. Now, you will also be given access to the video through our e-learning site, elearning.ability.my, where you can go to SPM, Form 5, for example. You have classes. Classes are for my tuition classes. E-courses is for the entire syllabus. All right, you can go to, for example, Form 5 at Maths, and notice that they are arranged according to chapter and also lesson. You can click on the lesson, and then you go to the video one by one, click on it to watch it, right? So if you're interested in this, you can order directly by contacting us through our website or even by WhatsApp. Now, you can also purchase directly through our Shopee site at shopee.com.my/30p. Thank you. Okay, let's continue question number 9. So here we have a diagram that shows trapezium ADEF and triangle ABC. Now, it is given that AD equals 8x. Now, for me, once you're given the diagram, right, just label everything in it. It's easier for us to read directly from here. If your AD is 8x, right? So, and BE is 3y. I think we can write BE first. This is 3y. All right, and BE is 3/5 of BC, meaning the ratio is 3:5. Now, if your BC is 5, okay, if you're not sure, we can write this out. I can just write here. BC is 3/5. If I bring over, becomes 5/3 of BE. If my BE is 3y, my BC will be 5y. Now, if BC is 5y, then my EC will be 2y. Just label like this will do. Okay, I'm going to erase this. Now, at the same time, the ratio of AD to FE is 2:1. That means this is 2. AD is 2. FE is 1. Now, FE is the same as BAB. This is 1. So the whole thing is 8x. If you take half of it, or should I say FE is now half of AD, since AD is 8x, half of it will be 4x. So I'm going to label 4x here, rub this off. I'm going to label 4x here and label 4x here, right? Now, the next thing is you are supposed to express AC in terms of X and Y. So with that, it's kind of easy. You just read directly from the diagram. If I want to go from A to C, I can go A to B, B to C, right? So you can write AB plus BC. Since we know AB is 4x, BC is 5y, so it's 4x plus 5y. Okay. Now, next, line FE is extended to point M. Let me rub off this. Okay. Line FE is extended to point M. Extended here. Let's say M is over here, such that FM is 8/5 FE. Okay. FM is this whole thing, right? So maybe we can find FM first. FM is 8/5 FE. Now, we know FE is 4x. Now, this is not a pretty number. It's 32/5x, right? 32/5. And we are given BM is KAC. Now, if BM equals to KAC, meaning BM must be parallel to AC. So we can draw a line here. Yeah, BM is supposed to be parallel to AC, right? So we're supposed to find the value of K. So we know BM is now K times of AC. I know AC, but BM we have to find. We can find BM by going from B to E, E to M, right? E to M. Okay. Now, Well, maybe I shouldn't have found FM. I should just find EM straight away, because if this is 8 to 5, this is 8, this is 5, therefore EM should be 3, right? So we can do that way. So there's no point finding FM unless you want to go B to A to F, F to M. Also can, right? There's so many ways to do it. So my AC, I already know my AC is 4x plus 5y. BE is 3y. EM is going to be 3 over 8 of FE. Yeah. Should I say 3 over, not 3 over 8, 3 over 5? Because this is 3, this is 5. Can you see this is 3, this is 5? So EM is 3 over 5. Okay. 3 over 5 of FE. This one you can multiply inside 4kx and 5ky. Now we also know FE already. FE is 4x. So this is 3 over 5 of 4x. All right. This is 4kx, 5ky. Put them together. 3y plus 12 over 5x, 4kx, 5ky. Now, alternately, if you know FM, you can actually find EM. Another way is you can find EM by taking 32 over 5x minus 4x. So it's pretty easy as well. This is also 12 over 5x. You can do it that way. So if you don't want to do this step by step, but this one, a lot of steps involved, right? So you can actually use this and subtract first, and then you sub in later. Okay. All right. So I've got this already. I got x and y. But when you compare, please compare x and x. I'm solving for k. I compare this and this, right? So you can either compare x. The coefficient of x is 4k, and 4k is 12 over 5. K is 3 over 5. Now, if you want to compare y, also can. The number in front of y in this case is, let me use a color pen. I use green, sorry. This thing is blocking. I use green. Yep. This y I compare with this, same thing. My 5k is now 3k is also 3. Just do one will do, right? You'll be able to find the value of k. So I think this question is pretty easy. Yeah. Okay, moving on. Now, let's move up to part B. Now, this is a very interesting question. It's not difficult, right? It's just that it's application oriented using what do you call that? I and J. So here we have an airport, right? Q located to the north of airport P and on the west of airport R. Okay, so let's say we start by drawing P. P is over here. All right. Q is located north of P. Okay, maybe I draw here and west of airport R. I hope you have some sense of direction. Now, this is north, south, yeah, east, and west. All right. So when you say Q is located west of R, meaning R is here, and this is a right angle, R is over here, right? Okay. And okay, maybe I shouldn't draw too long because the question says the bearing here is the bearing of R from P is 036.87. I hope you have some basic knowledge about bearing because bearing used to be in mod math syllabus, but they removed it. But since you probably learned this in geography, yeah, and the lower form, so you know that R is 036.87. So this is 36.87. This is a bearing, right? Bearing of P from R. R from P is this. Bearing will add a 0 in front if the number is less than 100. So in this case, the angle is 36.87. All right. Now, an airplane traveled from P to R with this position vector, 900I plus 1000 to J. 900I means I'm going to the right by 900 kilometers. Maybe I write here 900. 1200 is this, 1200 kilometers. So remember, IJ goes 900, 1200. You go right first, then go up later. All right. After that, the airplane continue its journey to airport S, which is located 3000 kilometers on the north of P. Okay, 3000 north of P. Now imagine this, 3000 kilometers, 3000 multiplied with 1200. So this should be 1800. This is airport S, right? So in 2 hours, so I draw this line here, just complete diagram. So when you draw it out, everything becomes a lot easier. Now we want to find the speed of airplane after leaving airport R. So to find the speed, we need to know this distance, right? We need to know the distance of RS. We can just simply use, just by using Pythagoras theorem. 900 square, 1800 square, put a square root over. All right, let me just show you here. Square root 900, all right, plus 1800. I got 2012.46. Yeah, 2012.46. Actually, you don't have to write so many decimal points, but just use more just in case. And we're finding the speed. Remember, speed is distance divided by time, right? Your distance is 2012.46 kilometer. Your time is 2 hours. Yeah, you travel from point R to S in 2 hours. So just take this and divide it. Actually, you can do it mentally at 1006.23. Just divide by 2, 1 by 1. But we don't need such an accurate answer. I think if you write 1006 kilometer per hour is good enough, right? That is your answer. Okay, moving on to question number 10. So this is from the chapter linear law. So we have a table that shows two values of two variables, x and y, obtained from experiment. So they are related by this equation here. So what we need to do here is to plot 1 over y versus x, 1 over y versus x. So, okay, for 1 over y, very simple. We just use your calculator. Take 1 over 0.9. The first one, I got 1.1. 1.11. Now, to make it easier for us to read, you can just change the calculator, the decimal point, fix the decimal point to 2 decimal places. Yeah, that's easier for us to read. That we just type this as 1.11, right? Automatically converted to decimal. Now, 1 divided 0.5, I think you can do mentally 2.00. Yeah, not you can use a calculator. 1 divided 0.34 is going to give us 2.94. Yeah, automatically rounded over 2.94. And 1 divided by 0.23, this is going to give us 4.35. 4.35. Next, 1 divided by 0.18. This will give us 5.56 upon rounding off to 2 decimal, 5.56. 2 decimal points enough, but we don't have to give more. Now, next one, 1 divided by 0.16. This gives us 6.25. Okay, before we plot the graph on the graph paper, so one of the things I always do is that I use my calculator to determine the number, the gradient and y-intercept, right? So especially this calculator, I think this calculator is a lot more easier to use, but the silver one can work as well, okay? It's okay. I think I'll just show you the silver one instead. I think most students still using the silver one, right? Although the gray one, sorry, this one, the class-based calculator is a lot easier in a way. Okay, so let's just, first I would reset this. I don't want 2 decimal point anymore. I'll just clear this to all, reset all, yes. And then I'm going to key in my x value first. I press mode, go to 3 for stats, 2 for a plus bx. 2. So your x is 4.4. Okay, let's start with 4.4. Okay, let's do all the x value first. That's 6.4 and 8.6, 12, 14.9, and 16.4. So we got all the x value done. Let's move on to your y value. 1.11, 2, 2.94, 4.35, 5.50, 5.56, sorry. And last one is 6.25. Now, why do I do this first? If you watch my previous video, most of the state paper that I've discussed, I will always show you how to use this calculator. Just press AC, yeah, shift 1 for stats, go to 5 for regression, press 1 for A, press equals. Yeah, this represents your y-intercept. A is your y-intercept, negative 0.74, right? So I know if I were to plot the graph right, my y-intercept is negative 0.74. And my gradient will be shift 1 again, press 5 for regression, press 2 for B. B is your gradient, 0.423. Yeah, my gradient should be 0.423, or we can write 42 lah. So you know your answer should be around there, right? So if your answer, your gradient is close to 0.42 or 43 is fine. If your gradient is negative 0.7 or negative 0.8, that is fine as well. Okay, so it's very useful if you do this first, because sometimes when you plot the graph unknowingly, we don't know whether the answer is correct or wrong. Okay, all right. So I'm gonna plot because my scale is 2 cm to 2 unit, and I know my y-intercept is negative, right? So I would have to go down, a little bit below here, right? So we're gonna start right here. Okay, so I may have to readjust this. Okay, it looks like this. My graph should go all the way until the end here, because the largest value is 6.25. Okay, no need. You don't need to go all the way. Okay, anyway, let me just adjust it. This should be around here. This is my axis. Don't need to go all the way until the end. Until somewhere here will do. Okay. Sorry, it's a bit too high. So move it down to here. Okay. All right, I think this is good enough. Now let's draw the vertical axis. Okay, it goes all the way up. Okay, oops. How high? I think don't need to be too high as well. I think around here. I'll just put it around here. Okay, so because your largest is just, 6.25. Okay, let me just label it like this. Okay. All right, because my horizontal axis is 2 cm. You can go back and see here. My horizontal axis, the scale is 2 cm to 2 unit. My vertical axis 2 cm to 1 unit. So this will be over here. This will be 2, 4. Let me zoom in a bit hard for me to see. Yeah, maybe I should put my glasses on, right? Yeah, a bit hard to see. So this one is 4. The line is not very obvious. Okay, this is 4, 6, 8. My largest value of x is 16. This is 10, 12. Okay, let's see where I can go all the way. 14, 16. Okay, I think it's enough here. This is your x value. Yep. And for your, 16.4. Oh, it looks like I need to go further. 16.4, meaning I need to go further until 18. Yeah, sorry, 18. 16.4 is the largest. So, okay, let's do until 18 here. As for your y, the smallest is negative 0. We know a y-intercept is negative 0.7 or negative 0.8. So this is negative 1. This is 0, 1, 2. Okay, zoom in a bit. This is 2. This is 3, 4, 5, 6. Yep, 6 point something. I think 7 is enough. This is 1 over y. Okay, I've got my x, I got my y. So let's see. I need to plot one by one. First one is 4.4 and 1.1. 4.4, 1.1. Okay. Remember your x-axis is one box is 2, one small box is 0.2. 4.4 should be around here. 2 boxes to the right, 1.1 should be here. So I put a cross here. Second one, my point, let's go back, is 6.4 and 2, right? 6.4 will be here and 2. Next will be 8.6, 2.94. Yeah. 8.6. 8.6 will be here, 2.9. 2.9 is here, but 2.94, you can put 2.95 actually if you want. 2.95 is in between 2.9 and 3. Next one, 14.9 and 5.56. Okay, is this the next one? No, 12 and 4.35. 12, 4.35. 4.35 is in between. Yeah. Next, 14.9 and 5.56. 14.9 is close to 15, in between. And 5.56. Okay, 14.9, 5.56 will be in between. You can read 5.6 if you want. Yeah, it's in between. And last one, 16.4, 6.25. 16.4 will be here, 6.25 in between. There you go. All right, now we're going to draw a line of best fit here. Now, I know my answer is going to be, my y-intercept is going to be -0.7 or -0.8 around there. So let's draw a line of best fit. Wait. Yeah. Start from this point here, go all the way. May have to adjust it. Now, 0.7 or 0.8 around there. This is 0.7. Okay, I will move this up a little bit. You see? So it's quite nice. It passes through almost every single point. Okay, almost, not all. Yeah, we have 2 points below here. So I'm going to move this down a little bit. Right. So I can see that there are 2 points above, 2 points below. The first point is slightly below. The second last point is slightly below. The last point is slightly above. The third point is slightly above. My y-intercept looks like -0.7, which is okay because my answer is from the calculator is -0.74. So I know it's quite accurate, right? Okay, so let's just calculate the gradient and the y-intercept. Okay, maybe we find this first because the question says, find the value of y when your x is 8. Okay, when your x is 8, we can just move this up. Read from here, find your y value. Okay, my y value looks like 2.6 or 2.65 around there. Now you might get a slightly different answer. It's okay. It looks like 2.65. Okay. Yeah, this is 3. It looks like 2.65. Okay. 2.65 is in between 2.6 and 2.7. Okay, this is 2.65. Okay, so now what I need to do is to work it out. Yeah, what is your y value? From the graph, when x is 0.6, 1 over y is 2.65. My y value should be, use your calculator, 1 divide 2.65. My answer is 0.3774. Yeah, 0.3774. Now you might, again, I must say this, you might get a slightly different answer. Some of you may get 2.6, which is fine, right? Okay, now, how do you find the value D and F? Okay, so this is where you need to find the gradient y-intercept first. Okay, I'm going to do my working here. My gradient is, okay, and later I'm going to move up. So I think I've show the gradient here. My gradient from the graph, you can see from the graph, to find gradient, I like to pick 2 points. And the first point, of course, is your y-intercept. It's easier to read, -0.7. And then I like to use horizontal 5 boxes because any number divided by 5 is a nice number. Now look at this point here, 10. At 10, okay, sorry, it looks like a little bit to the right. Okay, let me undo this. Okay, where is 10? At 10, it is sit at exactly this point, 10 and 3.5. Yeah, 10 and 3.5. It looks like 3.5 here. Okay, so I'm going to calculate my gradient. So my gradient is 3.5 minus -0.7 divide 10 minus 0. This is 4.2 divide 4.2 divide by 10, 0.42. You can't do mentally, just use your calculator. So look at this, 3.5 minus, maybe I just change the mode back to this, right? Easier to see. 3.5 minus -0.7 divide by 10 minus 0. 10 minus 0 is just 10. Can you see is 0.42, which is correct. My answer, the actual answer is 0.423. I get 0.42. That's fantastic. Very, very close already. Yeah. this negative 0.7. Okay, so the next thing is we need to convert this equation here to linear form, right? So I'm going to do it down here. Take this and invert it. So when you invert, you get 1 over y. This is 2x minus f over d. Now let's split this into 2, okay? So when you split this into 2, you will have 2 over dx minus f over d. Yeah, so this is your big Y, this is your gradient, this is your x, and this is your c. So what we need to do is to compare our gradient with our gradient from the graph, which is 0.42, with our gradient from the equation. So we can say that your 2 over d is now 0.42. To find d, I will take 2 divide 0.42. There you go. I got 4.762. Yeah, 4.762. Okay. Now, as for your y-intercept, right? I know the value of d. My y-intercept from the equation is negative f over d. I know my d is 4.762. I compare the y-intercept that I got from my graph, negative 0.7. Let's just multiply over. Take this 4.762 multiplied with 0.7. We can cancel out the negative. My f value is 3.333. Oh, a lot of 3 here. 333. There you go. That's your answer. Now, again, you might get a slightly different answer, right? But how do I know whether my answer is correct or not? Yep, I did that earlier from the calculator, so I know it should be correct. Yep. Okay, so let's move on to question number 11. So here Amrin participates in a workshop to build a geometric model. He has been given a piece of wire to make cuboid-shaped box frame. So the volume of the box is 375 cm cubed, and the base length of the box must be twice the base width. Okay, so picture this. You have a box such that it looks, okay, let me just do a sketch. My box looks like this. All right. We don't know what's the height. We know that the length of the base must be twice the width. So this is 2x, this is x. Let's say the height is h. Okay, so it looks like this. Okay, so now they say by taking the base as x, right, show that the length of wire used is given as this. Okay, so I know if you're given volume, right, and you're given the length of wire, that means we're talking about P, basically like perimeter, right? It's basically the sum of edges of a box, right? I think we can start off with the volume equation, and we know our final answer has no x. So volume is length, breadth, height is 375. Since your final answer is in terms of x, there is no h. Yeah, sorry if I say wrongly. It has no h. I need to make h as a subject. That will be 375 over 2x squared, right? We make h as a subject. Now, when you have a box like this, let's count the edges. Find us. We call it the sum of edges. We have 2x here. 1, 2, 3, 4. So I have 4 of 2x, right? Let me write this as p because the question asks us to express p, the length of the wire used is 4 of 2x. All right. Now, how about x? How many x do we have? We have 1, 2, 3, 4. So we got 4 of x. How are your height? h, 1, 2, 3, 4. In fact, we have 4 of everything at 4h. So we can add this up. This is 8x plus 2. 4x is 12x plus 4h. And that will be equation number 2. Remember, every time you have two unknown, right, h and x in this case, you always have to form two equations. And we need to substitute equation 1 inside equation 2. By substituting h inside, yeah, you notice your h is 375 over 2x squared, right? We can cancel the 2 here with the 4 here, left with 2. Now, 2 times 375 is 750. You're not sure, you can just use your calculator. 2 times 375, there you go, 750. So your P is 12x plus 750 over x squared. There you go. You got this equation already. Yeah, my part A is done. Okay, part B, they say, find the value of x that makes P the shortest. Right, that means we are talking about minimum value. Right, we know we can use differentiation. In fact, this is a question from differentiation. Typically, you form the equation and then you find the minimum or the maximum value. In this case, we differentiate dp dx. Differentiate 12x, you get 12. Remember, differentiate this is negative 750 over x. Sorry, 750 times 2, 1,500, right? Then you divide by x, and then you increase the power by 1. Okay, I want to show you this method because I know some of you don't learn this. Yep, your teacher probably asked you to bring it up, differentiate, bring it back down. So I like to use the fast and furious way. I put a negative in front. I copy a times n, an. I copy x. I increase the power by 1. So what I did here is I put a negative in front, right? Notice that I put a negative in front here. I take 750 times 2, 1,005. I copy my x. I increase the power by 1. This is power 2. Increased by 1 becomes power 3. Yeah. So in a way, it's faster. So you don't have to bring it back, bring it up, differentiate, bring it back down. Yeah. So, yeah. Okay. Coming back to this part here. Now that I've differentiated this, we know maximum minimum happens when your dy dx, or in this case, dp dx is 0. So I'll let this be 0. Okay, what we can do is we can multiply everybody by x cubed, or you can bring the 1,500 over also can, since this is negative. I bring it over, becomes positive. Bring the x cubed up, bring the 12 down. X cubed is 1,500 divided by 12, right? I just switch the position. 1,500 divided by 12, it gives us 125. If your x cubed is 125, right? Cube root of 125, use your calculator. Cube root of 125, it will be just 5. Okay, so this is 5, right? I got my x value. Yeah, that makes P shortest. Now, in this case, the question didn't say show that P has a minimum value. So in this case, we don't need to do that. We know it has a minimum value, right? But since the question didn't ask you to prove that it has minimum, so it's okay. We don't need to do second order differentiation. Remember, if you do second order differentiation, right, and you get the value is more than 0, meaning P has a minimum value, right, then it's shortest. Yeah, we normally do that if the question asks us to show. Yeah, in this case, no need. All right, B Roman 1, we're done. B Roman 2, find the value, calculate the value of P. Okay, so we take the x value, sub inside your P here. So your minimum value of P, in this case, is 12 times 5 plus 750 over 5 squared. 12 times 5 is 60, 12 times 5. 750 divided by 5 squared, divide 25. All right, I will get 90. So the minimum length is 90 cm. This is in cm. All right, this is part B. Part C. Given that the price per meter of a wire is 180, how much should the organizer of the workshops need to spend for 30 participants? This one has nothing to do with differentiation. Yeah, it's just a normal, simple multiplication, right? So to calculate the amount you have to spend, right? Now, this is in cm. The price per meter of the wire is 100, 1 ringgit 80 cents. So we need to convert 90 cm to 1 meter. So very simple, 90, you divide by 100 to convert to meter. So one participant, you need 0.9 meter, right? You need how many participants? 30 participants. Each wire per meter is 1 ringgit 80 cents. So you just multiply by 180. So let's take 90 over 100, or you can just write 0.9 in meter. You multiply by 30 participants, then multiply by 1 ringgit 80 cents. So the price you have to pay is RM, 48 ringgit and 60 cents. 48 ringgit and 60 cents. Wait, did I see wrongly? Yeah, 48.60. Okay, next is question from section C, question number 12. The first one is on kinematics of linear motion. We're given V equals to HT square plus kt. A particle moves on a straight line, the velocity is given by this. And it is given that the particle stops instantaneously when t is 3, acceleration -3 when t is 1. So it looks like a passive question I've done before, right? So it's quite, I would say, a common exam question. All right. So here we can start by substituting t equals to 3. Now we know a particle stops instantaneously when the velocity is 0. Now when we sub t with 3, we can write h times 3 square plus k times 3. The result is 0. Now notice we can divide everybody by 3. So 3h, 3 square divided by 3 is just 3 plus k is 0. Maybe we make k as a subject. K is -3h. Now, to find velocity, to find acceleration from velocity, we can differentiate. We take this function here, v equals to ht squared plus kt. We differentiate velocity, get acceleration. And remember, when you differentiate ht power 2, bring the power 2 down, copy your h, copy t, reduce the power by 1, so this t power 1. When you differentiate kt, you're left with k. So this is your acceleration, and we know your acceleration is -3 when your t is 1. So let's sub inside 2h times 1 plus k equals -3. We'll just write 2h plus k equals -3. This will be your equation number 2. Now, I'm going to sub inside equation 1, sub inside equation number 2. My k is now -3h. This is -3. My -h is now -3. H is just 3. So as we substitute inside equation 1, we'll get our k. Our k is just positive 9. -3 times -3. Wait, h is 3. -3 times 3. K is -9. Okay, I've got my h, I got my k. Next, we're finding the time interval when the particle moves to the left, right? So now, when the particle moves to the left, right, your v is now less than 0. Okay, so we need to find the range of values of t. So we can start by taking your v. Now that I know my h is 3, 3t squared, k is -9, t less than 0. We take out common factor 3 and t -3 less than 0. Let's sketch our graph. Yeah, the roots are 0 and 3. Right. Now, notice, I hope you know this by now, we are treating the whole thing as v, if you like. V is less than 0 if this region here, I can see here, this region here, it falls below the t-axis, right? At t-axis, v is equal to 0. Below t-axis, v is less than 0. So the range of values of t is between 0 and 3, right? So we say t is between 0 and 3. So we can, if you want to write the time interval, okay, maybe I should write like this, because this is the range of values of t, but the time interval or the length of time, yeah, the time interval, we can just take 3 minus 0, which is 3 seconds. All right. Now, last one. Calculate the total distance traveled by the particle from t equals 2 to t equals to 5. Okay, we already have this graph, right? So we can see that 0 to, maybe I just extend this a little bit, yeah? 0 to 2, the graph is below the x-axis. 2 to 3 is still below the x-axis. 3 to 5 is above the x-axis. Remember, distance under the graph, distance travel is the same as area under the graph for a velocity time graph. But part of the graph you notice is below the x-axis or t-axis. Part of it is above the t-axis. So we can use integration, definite integral, to find this area, right? So this is what I'm going to do. I'm going to integrate from 2 to 3 v dt. Your v is 3t squared minus 9t dt. However, take note, this area is below. So when you integrate, the result will be negative. So either you put a modulus or you put a negative in front. So for me, I prefer to put a negative in front. Then you plus with 3 to 5 And this is 3t squared minus 9t dt, right? So when we integrate, we copy t, increase the power by 1, 3, divide by 3, I cancel the 3, no more. Copy 9, copy t, increase the power by 1, 2, divide by 2. This is 2 to 3. And then this is t power 3 again, divide by 3, cancel out. In fact, you can just copy over. It's the same. Yeah, it's the same when you integrate. This is from 3 to 5. Now let's substitute 3 inside. 3 power 3 is 27. This is 9 over 2. I put 3 inside. 3 squared is 9. All right. And this will be minus 2 power 3 is 8. Right. 9 over 2. 2 squared is 4. Then I plus. Okay, by the way, there is a negative in front. You want to put a bracket here. Yeah, bracket here. This is now 5 power 3, 125. 5 power 2 is 25. Minus, copy the same thing, 27. 9 over 2 times 9. Okay. Now let's count. Okay. You can also double check with calculator. Okay, I'm going to show you how to double check using a calculator later. But for now, let's just minus directly 27. Oops, 27 first. You minus 9 times 9 is 81. 81 over 2, right? So we will subtract with, this is 8 minus 9 times, well, we can cancel these. Or if not, you can just write 9 over 2. 9 over 2 times 4. Yeah, you can cancel it actually. Then you plus 125 minus 9 over 2 times 25. And then you minus 27 minus 81 over 2. Okay, I can do one shot. My answer, okay, I don't know, maybe I've 22 and a half. Okay, maybe I've done something wrongly somewhere. Okay, let's see. This is, okay, I think this part here, 9 over 2. Okay, let me double check. Yeah, 8 minus 18. This is 18. 125. 125 minus 27. 9 over 2. It looks all right. All right. Okay, let's see. Maybe I've calculated wrongly somewhere. Minus and minus. Okay, let me just do it one more time. Okay, we know that if you okay, if you were to integrate, this is 27 over 2. Let's do one more time. This one minus 81 over 2, and then I minus, this is 8. 9 times 4 is 36, divided by 2 is 18. So this one is 18. Okay, let's calculate this first. I got 17. All right. 9 over 2. T squared. 3t cubed. 2 to 3. Yeah. 3 to 5. Minus 17. I think I don't know whether I made a mistake somewhere here. We can actually double check. Let's double check by using integration. Let's integrate 3 alpha x squared minus 9 alpha x. Lower limit is 2, upper limit is 3. So let's see. This is 7 over 2. So I've calculated this wrongly. 3 cubed 27. This is 90 squared. 81. 81 over 2. 2 cubed. Yeah. I can see that this answer is supposed to be 7 over 2. Okay, let's see. Negative 7 over 2. Maybe I've keyed wrongly or written this wrongly. 27 minus 81 over 2, right? And then you minus bracket 8 minus 18. Okay, see again. 7 over 2. Okay, yeah, this is 7 over 2. The second part, let's just use integration to validate again. We integrate 3 alpha x squared minus 9 alpha x. Lower limit 3, upper limit is 5. There you go, 26. So this is 26. Now you can count the manual way. 125 minus 9 over 2 times 25 minus bracket 27 minus 81 over 2. There you go, 26 is correct. So let's take 26 plus 7 over 2. Plus 7 over 2. Minus minus a plus, so my answer is 59 over 2 or 29.5. Yeah, the unit is in meter. Okay, question number 13. So this is from the chapter linear programming. Okay, so here we have a nursery that produces two types of organic fertilizer, type A and B. It is given a nursery produces X bottle of fertilizer A, Y bottle of fertilizer B. The ratio of A to B, organic fertilizer A to B, is at most 3:2. So I'm going to write the inequality here because part A, we need to write this 3 inequality. I think we can just write here directly. We know that organic fertilizer A is X, B is Y. So the ratio is at most. Now, at most means maximum. Maximum, we write less equals 3/2. Now let's cross multiply. We can write 2x less equals to 3y. Now for me, I would like to write y first. 3y greater equals to x, because we write y first a bit, because when you shade the region, it is based on y. I don't know, we look at y, more than is above, less than is below. Okay, my first inequality is done. Second one, the total number of organic fertilizer type A and B that can be produced does not exceed 80 bottles, sorry. So we say X plus Y does not exceed means less equals to 80. Yeah? It doesn't go more than 80. So maximum is 80. Now, next one. The number of organic fertilizer B exceed A by at most 40. So when we say B is more than A, so we say take the difference. B is bigger. You minus A. At most means maximum, less equals 40. Yeah. Yep. So y minus x less equals to 40. So I've got this 3 inequality. Now we have to shade. Yeah. The first part, we just write the inequality. I've done all that. Second part, they say using scale of 2 cm to 10 bottle on both axes, shade build and construct and shade the region R. Okay. So I think number one, maybe I will draw table values here. All right, I need some space. I'm going to draw my table values over here, right? So the first graph will be 3y equals 2x. So table values, we just use x equals 0, y equals 0, right? The second point we can use any point, but let's check the scale again. The scale given is, okay, let me move it back. The scale given is 2 cm to 10 bottle. So 2 cm to 10 bottle, maybe I just label here first. This is 0, 10, 20, zoom in a bit. All right, 30, 40, 50, 60. This is 10, 20, 30, 40, 50, 60. All right, I think I need to go all the way. Let's say, let me just move it over here. Maybe just go all the way to 80, 70, 80. This is my X, right? My Y is also, I think I'll just go up to 80. Yeah? All right, so let's draw the line, the axis here. My horizontal axis will be from here to here. Okay, move this a little bit lower. Okay, my vertical axis will be from here all the way up. Here. Okay, adjust a little bit. Okay, so this is my Y. All right, now let's go back to your table. We know that if your maximum is 80, your X value can put any number, but let's put the number that we can divide by 3. So maybe I put 60, right? So 2 times 60 is 120. 120 by 3 is 40. So it's 60, 40. 0, 0, 60, 40. Yeah, so I can see 0, 0 is here. 60, 40 should be here. Yeah, we can fit inside. Yeah. Okay. Oh, it'll be hard to see. I need to plot the point here. So let's just use ruler, draw a straight line, make sure it passes through these 2 points. Okay, let me adjust the line. The line I need to adjust it here. There you go. A little bit more. Yep, that's correct. So this is 3y equals 2x. Okay, so the second line we're going to draw is your x plus y equals to 80. This is easier. X plus y equals 80 because we can just use x equals to 0. Your y will be 80. Let y be 0. Your x is 80. So is 80, 0, 80, 80, 0. 0, 80, 80, 0 over here. Okay, so let's just draw. All right, my straight line should, oops. My straight line should start from here all the way down. Yep, there you go. X plus y equals 80. Yeah? X plus y equals 80. Okay, I think maybe can I adjust a little bit? Yeah, okay lah. I think it's quite okay lah. Not too perfect, but it's all right. Okay, next one. Y minus x equals 40. Yeah? The next one is y minus x equals to 40, as you can see. Yeah, y minus x equals 40. So let's start by taking x with 0, your y with 40, y with, now I can't put y 0 because when I put y 0, your x is negative. So let's pick a value more than 0. Your x value must always be positive here. Maybe I put 40, your x is 40, your y will be 80. Yeah, you can pick any other number. So 40, 80 is a bit high up, is over here, right? So let's just draw a line. Okay, make sure it passes through these 2 points. So 0, 40 is here. Okay, second one, 40, 80 is here. There you go. Let me adjust it a little bit. Okay. All right, so this is the line y minus x equals 40. So I've got these 3 points, these 3 lines already. The next thing is we have to shade the region. Okay, now how do you shade the region? Well, let's go back to the graph, the inequality here. So let's go back to the inequality. Look at the inequality given here. The first one is 3y greater equals 2x. So it must be above this axis. Okay, I'll just do a light shading here. Above this. Can you see that? Now, I know a lot of people tend to think that it's going to be inside because sometimes it's an open-ended region. It can be actually outside here, right? So it can be outside here. So number 2, you can see x plus y less equals to 80. So since it's above here and it has to be below, so it's either here or here, right? Below. So I know this part is out. So I cannot take this, leave it out. Okay. So what I need to focus on is these 2 regions only. The third one is y minus x less equals to 40. So we know it's going to be below here. Oops, it's going to be below here. So this is in, this is out. Okay, so let's now shade the entire region. Okay, entire region will be here. Yeah, and let's call it the region R. Yep, my graph is done. Okay, now next they say, okay, construct a region. So on a particular, there are only 50 bottles of organic fertilizer B are produced. B is Y, 50 bottle of B. You're finding the minimum of A produced on that day. So we start off with 50 over here. Zoom in a bit. This is 50 here. Let's move it across and move it down and find out how many bottle of A that you have. Okay, so you move it down. It's quite easy to see, right? Answer is 10. Okay, it's 10. So we say the number of bottle A is 10. Okay, next one. Find the maximum cost of producing the organic fertilizer on the day if the cost of producing a bottle of type A, type B are 20 ringgit and 30 ringgit respectively. So this is where we have to use the objective function. Now we know if you produce 1 bottle, you have to pay 20 ringgit for X for this organic fertilizer A, right? So if you produce X bottle, is 20X. If you produce type B, one bottle is 30 ringgit. You produce Y bottle is 30Y. And this is now K, right? So we just have to, number one, change it to Y equals mx plus c. Yeah? So I like to change to Y equals mx plus c because I just had to find out what is the gradient of this line. And we're going to draw this objective function line. The main thing is when you divide it, negative 203, the main thing is to identify which point that will give us the largest y-intercept. Remember, the bigger the y-intercept, the bigger your k. K is your cost function, right? The smaller the k, the smaller the y-intercept, the smaller the k value. So here we want to find maximum cost, right? So we're going to draw a line with a gradient of negative 2 over 3. So let me draw here. The line must have gradient negative 2 over 3. So for me, the y ratio must be 2. X ratio must be 3, 2 to 3. So let's draw 2 to 3. You can draw anywhere. Yeah. Normally we use a dotted line, but for this case, of course, it's easier for me to use a solid line here, but I just use a slightly different color. I use a blue color. Maybe I shouldn't use blue because it's a bit confusing, right? Same color. Okay. Hope you can see this is 2 to 3, maybe a bit lower here. Okay. Yeah, like I say, the main thing, the ratio is 2 to 3, yeah? And the gradient is negative, but it's a negative gradient. So we're going to take this line, we're going to move it up and down along this region and find which point gives us the largest y-intercept. Okay, so we can draw another line here. I'm going to draw another line here that's parallel. See, about parallel, you don't have to draw perfect lines. Okay, so I'm going to take this line and I'm going to move it up. Okay, so I'll move up here. Oops, sorry. Oh, something is wrong. Okay, let me just undo this. Okay, nothing wrong. Huh? Okay, is the whole thing just move? Okay, never mind. So I'm going to move only this line. Okay, now this, notice here, I can put at the few edges that we have, the few vertex that you have. The first one is here. Does this give us the largest y-intercept? No. No, right? Because you can extend all the way. It's not going to give us the largest y-intercept. Yeah. You can take this and move it down here. Again, it doesn't give us, obviously, it doesn't give us the largest y-intercept. You want the largest y-intercept here, you need to move it to this point. See this point here? This point will give us the largest y-intercept, right? Not a perfect position, but you can see how we can see, yeah, this point over here at the coordinate of 2060, it gives us the largest y-intercept right over here. Now, you don't want to calculate y-intercept from here because it's not accurate. This is just a point, the line that we draw, we just move it up and down and find which coordinate gives us the largest y-intercept. So answer is 2060. All right, let's go back to this calculation here. So we say that K is maximum at 2060. And to find maximum cost, maximum value K, we sub inside here. Your X is now 20. Your Y is now 60. Now let's use our calculator. 20 times 20 plus 30 times 60. This will give us 2,200. The maximum cost of producing this fertilizer will be 2020. Okay, so question number 14 now. So diagram shows a triangle PQR such that PQR is obtuse, and you have straight line PAB intersect AR at point A. B is a midpoint, so B is a midpoint. Maybe straight away I can say B here, right? 6.99. I divide by 2, I get 3.495. So this is 3.495. This is the length of PR. Okay. What else? They say that you're supposed to find length of PQ. Also, 2PA equals 3AB. So maybe I say PAAB has a ratio of 3 over 2. I bring the AB down. I bring the 2 across. I hope you can see this. AB goes down, 2 go across. right? So your ratio BAAB is 3:2. Okay, so BAAB, my B here is a bit ugly, sorry. BAAB 3:2. And the shortest distance from Q to straight line PR. Q to straight line PR is this. This is your shortest distance. And your shortest distance is 5.36. Okay, maybe I highlight here. This distance is 5.36. Okay, I'm supposed to find the length of PQ. Now, if you look at the triangle as a whole, right? So this is my PQR. Let's just draw like this. This is my PQR. I know this length 6.99. I know this length 12.01. I want to find this opposite length. Now, the problem is I don't know this angle. I don't know this angle. I don't even know this angle. So now we can't use sine rule, can't use cosine rule. So I need more information. But you will observe that the information given here, they gave us the perpendicular distance from Q to line PR. Now you can call this N, and maybe we use N because N is normal. This is 5.36. This is R. This is 6.99. Now we don't have to use sine rule, cosine rule here. We can use the basic SOHCAHTOA. SOHCAHTOA means sine, cos, and tangent, right? To find angle QRN first, or QRN or QRP. They are the same angle. So let me write sine angle QRN is your opposite. Guys, your opposite is this 5 point. Maybe I draw here, easier to see. 5.36. 5.36 divide 6.99. Now use your calculator. 5.36 divide 6.99. Whatever I get here, shift sign, answer equals 50.07, right? Angle QRN is 50.07. Okay, once you got this angle, okay, I can now use cosine rule to find this. This is 50.07. Remember, cosine rule works this way. If you're finding the length of the opposite side, which is A squared, it is now B squared plus C squared. The other two sides square add together, minus 2BC cos A. Yeah, this is the formula for cosine rule. Now my A is now PQ. I square it. My B will be 6.99. I square it. My C is 17.01. Sorry, 12.01. Yeah, 12.01. I square it. Minus 2. Your AB is 6.99. 12.01. Cos of the angle in between. The angle in between is now 50.07. Okay, let's use our calculator. Let me show you here. Now, we start by writing 6.99 square root plus 12.01 square root minus 2 times 6.99 times 12.01 times cos 50.01. 07, sorry. Close bracket, there's equals, square root, answer equals. I got 9.3238. BQ is 9.238. You don't have to write a lot of steps, but please don't go and calculate and leave it in decimal and then square root. Yeah, do it one shot, do it one step. Yeah, after all, only 2 marks given, 1 for formula, 1 for final answer. Right? Writing additional step is just not necessary. Okay, I've done part A. I got the length of PQ. Next, I want to sketch the triangle. Now here they say you're supposed to sketch triangle P prime, Q prime, R prime, which has a different shape from this triangle. Yeah, such that PQ, P prime, Q prime is the same as PQ. That means you're maintaining this length. Q prime, R prime is the same, and angle QPR is the same. So here's the thing I want you to know about ambiguity. Let me just do a rough sketch, simple sketch for you. It looks like this. This is your original triangle, okay? Something like that, okay? P, Q, R. You want to maintain this length, you want to maintain this length, you want to maintain this angle. Now, the idea of ambiguity or ambiguous case happens when the opposite side of a given angle, this angle is given, is shorter than another given side. Your QR is shorter than PQ, right? So then one, you have to understand it must be shorter. Okay, number 2, that means in this case, yes, we have ambiguous case. Number two, the two given length that you have, right? I already know this length, 9.238. I know this length, 6.99. Okay. The two given length that you have, right? They both meet here at Q. So you're going to treat Q like your hinge, if like door hinge that you can flip open and close. So this is your hinge, the point. Yeah. I'm going to flip this inside like this. Okay. Just a sketch you do. Don't draw perfect line. Okay. And I know that I can join this together to form the second triangle. Now, this triangle, you notice it has the same length here, 6.99, right? It's the same. And I'm still maintaining this angle. Yeah, over here, angle PQPR. We just want to add a prime for this. All right. Okay, let me redraw nicely. 1, 2, and 3. Okay, not very nice. Erase the rest. I don't need the rest really. All right. Okay, sorry for the double line. Okay, so it looks something like this. This is 6.99. So this is the triangle that we have to draw. You have to sketch. Yeah? So there you go. You maintain the length of these two sides as well as angle QPR. All right. So this is B Roman 1. Now, hence, state the size of PR prime Q. Now, notice just now previously we got this angle as 50.07. And if I were to extend this, right, and extend this, we know this is 50.07. In fact, this is also 50.07 because they are equal length, isosceles. And therefore, the angle next to it should be 180 minus 50.07 because it's a straight line, right? So I can just erase this. I don't need all this thing, right? What I need is this angle P prime R prime Q prime, which is 180 minus 50.07. This gives us 129.93. 129.93. Yeah, you just have to state the angle. I don't have to do a lot of complex calculation. Okay, next we want to calculate angle QPR. QPR, this angle here. We already know this is 129.93. I define this angle here. In fact, we know the length and the opposite angle, right? Or should I say the angle, the opposite length. So we can use sine rule. Sine rule works like this. If you're finding Q prime, P prime, R prime, the opposite length is 6.99. So you're going to divide by 6.99. Okay. Then we know that sine of angle 129.93, we can divide by its opposite with its opposite length. The opposite length is 9.238. Okay, let's use a calculator. All right, let's take sine of 129.93. Oops, 129.93. We divide by 9.238. Whatever we get here, we multiply by 6.99. Okay, whatever get, again, shift sign, answer equals 35.47. Yeah, angle Q prime, P prime, R prime is 35.47. Yeah, there you go. I'm done up to here. Okay, I'm going to do my part C over here. Lastly, find the area of triangle ABR. Okay, this one is very interesting. Before you find ABR, okay, maybe I should find a PBR. Why? Now, if you focus on this triangle, you see, this triangle PBR, look at this PBR. This is a full triangle, okay? Now, the difference between triangle PBR and ABR is that ABR is the, oh, maybe I highlight using this. ABR has a smaller base. They both have the same height, if you like. Yeah, because they are on the same line right here. So maybe I draw the triangle here has a height outside. Yeah, I hope you know this. When you have three types of triangle, this is your base, this is your height. For this case, it's an acute angle triangle. The height lies inside the triangle where the base and height are perpendicular. You have a right angle triangle like this, where base and height are perpendicular here. And you have what we call an obtuse angle triangle, where the base, okay, sorry, once again, where the base is here, but the height lies outside. Okay, but in this case, it's upside down. I reflect. Yeah, you get to rotate it to be able to see it. All right, where the height is actually outside. Now, for ABR, the base is this. For PBR, the base is longer. The ratio is 3:2. So we use this way because it's easier. We can just compare the bases, yeah, the different length of the base. So let's start by finding PBR. Okay, so area of triangle PBR. The thing is, I know this length already. See this? I know this length already, and I know this angle, right? So we can use half AB sine C. Remember, area triangle is given by half AB sine C. Rather similar to cosine rule, AB are two sides, C is an angle in between. We call it included angle. So I start by finding PBR. Okay, so I take half your base, your AB sine C will be 12.01, 3.495, sine of your angle 50.07. Okay, so use your calculator. Half times 12.01 times 3.495 times sine 50.07. Okay, guys, my answer is 16.094. Maybe I use one more decimal point, 16.094, because I will need to use this result to find triangle ABR. Okay, my area triangle ABR, like I say, if you take the ratio with triangle PBR, ABR is shorter. The length here is 2. PBR is longer. The length, overall length is 5. So it's 2/5. So basically, ABR is just 2/5 of PBR, which is 16.094. Let's count. Let's take this 16.094 multiply 2/5. Guys, my answer will be 6.438. Yeah, if you round off 6.438, yeah, 4 significant figure will do. Right? Okay, let's move on to the last question. This is index number. I'm putting it next to each other, easier for us to see, so I don't have to move up and down. So here we have a diagram that shows distribution of material usage to make jewelry, and the price index is given in the table. All right, so here the first part, okay, this is, oh, there's a double overlap here. So we are supposed to find the value of P and Q. Okay, maybe I move this up a little bit. Sorry, this one is overlapping with the earlier one. Let me just delete this. Sorry. All right, so there you go. Now, we're supposed to find the value of P and Q. P is a price index for the pearl. Now you can see for the price in year 2019 is 250, 250 over here. Price in 2020 is 270. So I'm going to do my working over here. All right, so the price index for your pearl, yeah, is P. We take 270 divide by 250 times 100. Yeah, very simple. Calculator, 270 divide 250 times 100. That will give us 108, right? So this is straightforward, 108. Now for Q, right, this is still part A. Q, we are looking at the price for the nylon string in the year 2020, and the price index is 145. The price in year 2019 is 180. So let's take Q divide 180 times 100. Let it be 145. And to find Q, let's take 145. 145 multiply with 180, right? Divide by 100. I got to divide by 100. So my Q is 2 ringgit and 61 cents. Yeah, 2 ringgit and 61 cents. You don't have to write RM because this is already in RM here. See the price, sorry, RM, just write 2.61. Okay, next, part B. the price of a hook is expected to increase by 12.5% from 2020 to the year 21. Calculate the price index for 21 based on 2019. So whenever you have, should I say, two consecutive indices given for the hook, we know this 130, all right? I like to use this, what we call simplified chain rule. So this is 2019, this is 2020, this is 2021. From 19 to 20, the price gone up by 30%, 130. 130 means increase by 30%. From 2020 to 2021, increased by 12.5%. So index-wise, we write 1 to 5, 1 to 2, 1 to 2.5. Yeah. Sorry, I wrote wrongly. 112.5. Yeah, 12%, 12.5%, 112.5. So to find the overall increase, we just take these two consecutive indices, you multiply together, divide by 100. Okay, let me show you here. 130 times 112.5 divide 100. Guys, I got 146.25. Yeah, this is 146.25. Okay, we're done. Now let's move on to part C. Okay, now in part C, they say, calculate the composite index for the cost of making the jewelry in the year 2020 based on the year 2019. Now, to find composite index, you must take the individual price indices, multiply with the weightage. Now, we have almost everything. In fact, we have E as well, right? B, earlier we got 108, right? We just had to find the weightage. Now, weightage are usually given in the form of pie chart, bar chart, or any other percentages. Yeah, given. Now, look at this. The angles are all given, except for the hook. The problem is crystal bead is given in percentage. It's quite misleading because a lot of people think it's 15 degrees. It's not 15 degrees, 15%, right? So if you want to find the angle for crystal bead, right, we take 15 over 100 multiplied by this 15% over 360 because you want to find the angle for the crystal bead. So let's do 15 over 100 multiply 360 and I got 54. So the angle for crystal bead is 54. Now, not only that, we need to find the angle for the hook. Yeah, the angle for the hook. Maybe I just put an arrow here for the hook. We take 360 minus 162 minus 54 and minus the angle for nylon string 108. All these are angle in degrees. So let's take 360 minus 162 minus 54 minus 108. I got 36. Your angle is 36 degrees. Right, so I've got all the angle that I need. I just had to find a weightage. Okay, so for angle, maybe I list out here. Pearl is 162. Crystal bead is 54 degrees. Nylon string is 108. Hook is 36. So all these are in angle, but we need to find weightage. Yeah, weightage usually we have to simplify to the lowest term. It's easier for us to calculate. Now notice that everything that they're divisible by 18. I can divide 18. Now, if you're not sure, you can just do one by one. You can divide by 2 first, divide by 3 first, until you can't divide anymore. So I think 162 divided by 18, I got 9. Let's take 54 divided by 18, I will get 3. Right? 108 divided by 18, I got 6. 36 divided by 18, I got 2. Right? So I got the angle, the weightage. I've got the price index. I can now calculate the composite index. So let me just write my composite index over here. All right, let's move this to the right a little bit. Right. So since I have everything I need here, I'm going to take that index. I'm going to multiply. Index is 108. I multiply weightage 9. Then 120, I multiply by 3. 145, I multiply by 6. 130, I multiply by 2. Divide by my total. My total weightage is 9 plus 3 plus 6 plus 2. Okay, so let's count. Use your calculator. Okay, first one. Let's take 108 times 9. 120 times 3. 145 times 6. 130 times 2. divide total weightage 9, 3, 6, and 2. And I got my answer as 123.1. 123.1. Yep, that's your composite index. Okay, now, last part. The cost of all materials increases by 10% from 2020 to 2021, right? If the cost of making the jewelry in the year 2020 is 2 ringgit 50 cents cheaper than 21, find the cost in 2021. So here's the thing, cost in 21, we don't know. But we know cost in 2020 is whatever in 21, but it's cheaper. So you minus 250. Now I know if you go and put the superscript, subscript, it's a bit confusing. So maybe I just call it P. You can call it C, cost if you like. So this is 2 ringgit 50 cents cheaper. So whatever P value I have, I must minus 250. Now actually this one has nothing to do with the earlier one because we are only concerned about the price index or in the increment from 2020 to 2021. Now, what we have here is from 2019 to 2020. So nothing to do with the earlier part. So I'm going to write like this, price in 21, which is P, divide by price in 2020, which is P minus 250. I multiply by 100, it increased by 10%. Now, 10%, we have to write 110, right? So let's just simplify this. Okay. In fact, if you don't like a fraction, right? If you don't like the number like 100, you can just divide 110, divide 100, change to 1.1 if you want. Okay, I'm just going to write 100 here. P, this is 110 P minus, take 250 times 110. I get 275. Remember, I want to find a P, bring over. 10P is 275. 110 minus 100 is just 10. P is 275 divided by 10. We can write RM, 27 ringgit and 50 cents. Yeah. So the cost of making the jewelry in the year 2021 is 27.50. All right. I have come to the end of the video. Thank you so much for watching. I hope you learned a lot along, the way watching this video. Yep. I hope to see you in the next video. Thank you.